Up next, we've got Benjamin Johnston. Ben teaches software, entrepreneurship, and creativity here at UTS, in fact, in this very environment. And his research concerns how artificial intelligence and robots will relate to people. He's also Deputy Director of the Innovation and Enterprise Research Lab, where he and the team work to bring socially intelligent robots into our everyday lives. Ben's research looks to give robots the common sense they need so that they can understand enough to figure out how to make people happy. If it works with robots, next up he's going to work with lawyers.
Yeah. So I thought I'd just start off by showing some family photos. In a robotics lab, our family photos are a little bit different to your family photos. They involve robots. So this is a PR2, the only one in the Southern Hemisphere. It's worth about $250,000, and it's designed to run 24/7. We use it to explore how people and robots work with each other. So here we're doing some experiments to understand how people interpret robot actions and how robots can interpret people's actions and make sure they have seamless collaboration. We also work with pepper robots, explore how they influence people, how we can teach people with robots. So this is a classroom, they're just being taught by the robot, and they're doing a test and we're just seeing how well they learn what the robot taught it. We've been working with Commonwealth Bank, and this is their Jason-style robot that it's designed to... The bank's interested in exploring how people and robots work together, of course, like we are, and we've been doing projects involving retail and guidance and assistance, and seeing how to make these robots convincing and compelling. About 10 years ago, we were in RoboCup soccer, so we were programming these little robot dogs to play soccer and compete at the World Cup of Soccer. Eventually, that league evolved into this humanoid league, playing soccer with these humanoids. We retired from that game after some successes to focus on research, but now we're back at RoboCup again with these humanoids in a different league where we're, rather than playing soccer, we're competing to see who can create the most convincing, compelling robot. And this is the environment. It looks like a home. It's designed to be a home, and we're trying to build helpers. So in 10 years' time, you'll all have a robot at home, doing the dishes, vacuuming the floor, putting your kids to bed, making life easy for you. We're a team of many people. That's Steve Wozniak, who's a member of our lab. Yeah, we're actually a software lab, so we buy our robots, but we focus on the AI. And if you're into robotics, RoboCup is your dream come true. This is just one corner of RoboCup. We've got robots of every type spread over a massive arena. Okay, so that's a little bit of fun. Where are we going with robots and AI? And I think the best way to do it is look at the past. So this is 20 years ago. And this is a game of robot soccer. And they're terrible. They're absolutely abysmal. Like, they can't stand up. Their walking's clumsy, and they're playing like kids. They're playing soccer like kids. They're all surrounding the ball. There's no strategy here. It's an embarrassment. But that's 20 years ago. They're struck, where is the ball? They have no idea. Momentary lapse in Wi-Fi. So the next year, so another 10 years later, and we get to improved robots and improved programming. So this is actually when we unleashed the first dodge in soccer. And what you can see here is they've got control of the ball. They've changed, their walk has evolved. Before they used to walk on their hands, but now we figured out that actually they're faster on their elbows, on their knees. And you could see that was a moment where there was a bit of strategy where it stepped aside and kicked the ball. So that's 10 years ago. What is it today? This is today. So we're not competing in RoboCup soccer anymore, but these are the best teams in the world at RoboCup soccer. And is beautiful. So what you'll see, like this walk, it's natural, it's energy efficient for a roboticist. You can see that this is an energy efficient walk. They go into position without guidance. There's no more barriers around the field. We used to color code everything on in the match, but now it's all just like you don't know which end's which if you're a robot. The robot has to figure out which end is its own end, so it doesn't kick own goals. And the ball no longer is a brightly color-coded ball. It's all this is getting close to real soccer. It's getting exciting. And they're working as a team. You can see they're keeping their distance. What I think.
Leipzig ist auch ein Team, das bekannt dafür ist, sehr gut zu stören, sehr schnell am Ball zu sein, auch am Gegner vorbeizudribbeln. Das sieht man hier jetzt sehr gut.
Can I just say also, I love that there's this match of five-a-side robots playing soccer. How often do you see this in the world? And we've got this person here reading a book or something. The World Finals of RoboCup Soccer. And obviously that reading is obviously much more important. Okay. So, well, they fall over, they have to get back up. It's fully autonomous, there's no remote control. They have to play soccer themselves without us giving guidance. So that's 10 years, 10 years. Looking ahead another 10 years, it's not that hard to imagine these really being with us everywhere, as competent as people. And just to give a sense of this is some more videos of the state of the art. So who can do a backwards speed reverse park, what do you call it, a handbrake reverse park at speed? No one in the room can do it. But, of course, self-driving cars, a few years ago, were already able to master this. This is a process of experimentation. With one control mechanism, it's a failure. With the other kind of control mechanism, it's still not good. But now all of our self-driving cars are, in theory, able to pull off a beautiful, successful handbrake reverse park maneuver. So this is what your self-driving car will be like in 2 years' time. And many of you have probably seen this video. This is Boston Robotics robot. And there isn't really that much difference fundamentally between the RoboCup soccer robots and these robots. What's amazing about these is the machinery itself. It's a huge advantage in machinery. This would probably cost in the order of millions of dollars to build. Whereas the RoboCup robots are a lot cheaper. So it's just really economies of scale and cost that is the difference between the two. Not to deny that this is an amazing piece of engineering. This is absolutely fantastic as well. But in 10 years' time, this may be the kind of thing that we have affordable. So how does this work? What is a robot? What is AI? And I think AI and robotics are really partners of each other. Robots are just such a visual way of understanding artificial intelligence. We have a robot. What does it do? It senses the world, it does some thinking, and then it acts on the world. Pretty straightforward. So let's break that down. I've got a scenario here where I'm going to ask this robot for help, and I'll just show you what's going on inside the robot. So first of all, it's looking at the world, so it captures an image. And of course, robots can't see like we see. All this is a set of numbers. It's raw data. And so it has to run this through some neural network. So the first neural network, it's just a machine learning technique. It'll identify the key points on my body and narrow into my face. Because so much of human social interaction is about gender. Like we talk about, he went to the park, she went for a run. Gender is such an important part, age is such an important part. Being able to interact with people, knowing whether they're a child or an adult, is an important part of this social interaction. So we now go into the face, and then we do some pre-filtering to get rid of the any lighting changes and things, make it more consistent. Once we've done that, we've got this huge database of faces we've seen before. This is just a sample of 100,000 faces we've got collected, classified by age and gender. And then we run a machine learning technique, the same technique we use to identify the skeleton. We use it on the faces here. And if we look inside those internal mechanisms, it generates this kind of way of, these are the patterns it searches for in the image. And this is kind of cryptic. And you look at it and it just looks bizarre. It seems meaningless. But if you squint, you can kind of make out some things in faces. So this is like a smiley face. I think this here is a chin of a man. Here's two eyes. There's two eyes and a nose. They're vaguely there. And what the robot will do is associate certain patterns with certain faces. So on males, you have like beards and here two eyes. So this is bald men. And essentially, it's learned this rule that men are people with a beard and a bald head. Definitely. If they've got one of those two things, they're definitely a man. If it's not definitely a man, then you can tell the difference between women and men by the length of the hair. That's really the essence of this rule. Here you can, there's sort of like a pattern here. Pick out like the left and right side of the woman's long hair. But this rule is pretty effective. On the data set, it's like 90% accurate. And so when it ran with my face, it popped up this one. And I think what's going on is that I've got dark eyebrows, and so that's a male feature, and that's why it's picked up that I'm a male, based most strongly on this feature here. So we pull out some properties. Here's me, narrowed in the face. We then start thinking about, so this is the sensing. Internally it starts thinking, where this is more about a rule-driven process. Okay, it's probably male. The hand is above the head, so there's a waving gesture. When we say male waving, we say hello sir. And then the response is we have to go and start solving some problems. So behind the scenes, if it wants to wave, the goal is to get the hand here. So it just internally starts imagining, okay, I want my hand here. Do I do it this way, this way? Well, this makes it closer. I'll try it again. Now this joint, what's the right angle to get to as closest to the point? It keeps iterating over and over again until it finds this right configuration of joints. And then it just plays those joints out. So now to wave, it's just worked through all this searching every single second. It's done it, imagined millions of times to work out how to do the joints to wave back. Okay, that makes sense? And when we pull it all together, we get what hopefully looks like a semi-convincing interaction.
Hello, sir. How may I help you?
Where is the cafe?
The cafe is to your right.
Thank you.
You are welcome.
Okay. It's kind of a silly demo, a simple demo, but behind the scenes there's a huge amount going on. And really this is the core of AI. We've got two things going on. We've got this shallow snap judgments in that sensing phase. It's just this quick recognition of images. So that was detecting male or female, detecting my skeleton. And this deep search, tracking through all the possibilities and figuring out what combination will get you the goal you need. Our ultimate challenge is bringing these together in a nice way. At the moment, we haven't really got there, and so leading computer scientists really have two perspectives. One is that what we think is hard, like playing chess and playing Go, is easy for a robot, for a machine. But it's these basic things like standing up here, balancing, navigating environments, that's hard for a robot. And this is kind of our big challenge for robotics at the moment. On the other hand, we also have these neural network researchers who are arguing that actually we're almost at the point where any of those instant gut reactions that take less than a second of thought we can really automate on a computer. So looking at a picture and spotting where the person is, that takes about a second of thought. The computer can do it. Looking at a scene and deciding whether you need to steer left or right in a car, that's about a second of thought. Do a whole pile of them and you're driving. Okay, so what about the challenges? Now this is where I'm not really a lawyer, and I'm going to tell you a series of stories, and then you can use your legal side to interpret these stories and weave it into a coherent whole. And from my point of view, there are a number of challenges that as robots enter the world, which we're going to face. We're facing them in research labs, but as it comes out into your world, it's going to be uncomfortable and difficult, as it replaces jobs for one thing, which I won't even touch on, but even just having them in our homes. These machines are incredible. They've got not just cameras, they've got laser scanners, microphone arrays, thermometers, accelerometers. When I pull out my phone and point it at you, it feels kind of aggressive when I'm recording something. But the robot there is really a surveillance system, watching constantly, and it just doesn't feel that aggressive. Yet it's there, recording. It can monitor your heartbeat. You can extract heartbeat from video. It's watching where you're looking. It knows when you gave a dirty look to the other person over there. I don't know if you really did, but it knows it really knows everything. This whole room could have been tracked to the millimeter, and this is data that we don't really know what to do with. It's really personal data, and these machines will have it. They'll know your exact waist measurements because they've got laser scanners scanning the room. They'll know whether you put on weight the last week. They know everything. The next thing is that they're going to be in places where we're not going to be comfortable. We haven't had technology before in our, this is a map of our research lab, but they'll be mapping our homes, hanging out in our bathrooms, seeing children in their bedrooms when they're getting changed. They'll be potentially everywhere in a home. And we can't just have them like Siri and Google where they turn on command, because we want them in our home helping us. We'll want them to see, oh, you're carrying 5 bags, let me help you with that. It's really a change from this sort of passive mode of, let me help you when you ask, to I'm watching you, let me make your life better. Baked in, there'll be a whole lot of assumptions, and this is really from the designers of the system. So this is a great video. If you look on YouTube, you'll find a video where someone has discovered a racist soap dispenser because his skin is dark, but the engineers who programmed this had light skin. So putting his own hand under it, it wasn't bright enough to activate the sensor. And our robots, really, it's going to be based on the data sets that they're trained with. That face detection thing, I've trained it with a whole lot of data from Wikipedia. So there aren't many disabled people in Wikipedia, there aren't many transgender people in Wikipedia. Understanding all of this nuance is not the kind of thing that AI is able to deal with, because it just doesn't understand itself what it's doing. It's just following simple pattern recognition. There was another one I was going to say about that. And it's got the potential to be, even in seemingly innocuous situations, we've got this potential for discrimination. Microsoft Research has a system where if you walk to an elevator, it'll automatically call a lift and select your destination floor for you automatically. If it learns over time that in general, say people with dark skin don't normally go to the top floor where the executive lounge is, then in time it's going to just learn that rule that it's only white people who go to the top floor, and so if you're white you'll get automatically sent to the top floor. If you're not white, you might be sent to the mail room because of the pre-existing assumptions that have now been carried forth and embedded into the AI system. We bring pets into our home, and I view robots in 10 years will be like pets, but weird pets that are connected to Google and monitor our every move. So if you've ever had your cat watch you while you're using the toilet, that maybe seemed okay because the cat can't go and gossip to all your friends about it, but now your cat can upload your embarrassing photos to Google and make you feel uncomfortable, to say the least.
Potentially could, and that's the problem, isn't it?
Yes,
Potentially.
exactly, potentially, yeah. And because they're in this active state all the time, they really need to be monitoring constantly. And in fact, furthermore, it's difficult to have these running offline. You need to be connected to the web so that they can improve their learning constantly. So it's not like we can have them running offline and use them on demand, and use them without internet connection. They truly depend on connectivity to central servers, because that's just how they get better and learn from the environments and deal with the fact that the world is so complicated. Security and safety is obviously an issue. These robots are dangerous, they're heavy. That robot I showed you at the start could if it was on top of you, you'd break some bones. It's heavy. These are not safe things. This particular robot is a security robot that obviously navigation has gone wrong and fell in the pond. But security is already an issue. In our own research lab, we've had, well actually almost every research lab can tell you a story where someone's gotten locked out of the office and they realise, okay, can't get in, I could go and call security and get them to come, or I could just break into access the Wi-Fi network, access the robot and get the robot to come to the door, to open the door. And these things happen all the time in robot labs around the world. People bypassing security by breaking into their own offices via robots. And robots are not secure. They're like cheap. We don't want them to evolve quickly. We don't want them to have the latest software updates. So they're insecure. And I can tell you, in the past, we've had this problem before. One of our robots, we didn't know there was another account on the system. It was on page 100 of the documentation, and who reads the documentation? So we didn't realize there was this extra secret account on the system for maintenance, but someone on the internet managed to brute force guess the login for this robot. They just used it for spamming. They didn't realize they were connected to a robot. But if they knew it was a robot, then who knows what damage they could have done. We've since upgraded our security a lot. And then explainability, like this is how the robot thinks, this is how the robot makes sense of gender. We can't make sense of this. How can we even talk about whether the robot's discriminating or not when we don't even know what's going on here? This is what defines womanness. Like, how do you even make sense of this? And this is, I designed this to be explainable. I set up the machine learning algorithm so I could create these cool visualizations. The default system I would have used is completely non-understandable. These are the understandable versions of AI. The behind the scenes, it's just impossible. What can AI do? All of that. What it can't do at the moment are these things that involve high-level thought and reflection. So all of these things that involve understanding itself what it's doing. We can't understand this. It can't understand itself what it's doing internally. And so anything that involves this kind of level of intuition, self-awareness, synthesis, is really remaining as a challenge for artificial intelligence. And who knows how long that's going to take with AI. Sometimes these discoveries come sooner than you expect. And so what does this mean for law? Well, you're the lawyers, you can tell me. But a lot of these techniques that happen in robotics apply exactly the same in textual processing, in legal processing. We have this rule processing side, that right-hand side of that deep search is an aspect of the legal processing which our previous speaker was just talking about, and Rita will as well. And making sense of text is more on this other side. It's like the vision, gut reaction processing. Text is just, to a computer, it's just a set of numbers. And you're searching for patterns in those numbers in exactly the same way as you might be searching for patterns in images. The same process, but kind of bridging the two between that probabilistic interpretation and that search remains as a challenge for AI. And then all those things I've spoken to before, like, well, what's the role of AI what's the role of law in controlling, guiding these robots? And conversely, I think there's also an interesting aspect in what's the potential of AI in guiding law. So that's it. I realise I've spoken a little bit fast, so I've got a bit of time for questions. Yeah.
Hi, thanks for that. So you mentioned a little bit about how when we introduce AI into our households, they're going to have access to this new level of personal data and information. And we don't really know what to do with that yet. And on top of that, not a lot of people know that the information is being extracted to that degree. So where do you see that going? Do you see like companies trying to sell that information even more so than they do now? Or?
Great question. I think I would say if we continue the trajectory we're going at the moment, I imagine it'll be handled a lot like Google handles their search queries. They're collecting a lot of private information. If I type in why am I sick, then it's got that data there. And I think that large organisations, if we just follow the pattern we've got in the past, it'll be a similar approach. Here's your data, we promise not to look at it too much, we promise not to identify it with you. But I don't know what the solution is. This is really what I think the role of law is, to help with this, to say that this is appropriately used, this is how we'll store it. And the challenge is also that it's hard to anonymise it. It's one thing it's like, I'm feeling depressed as a query, that's easily anonymised, but a photo of you crying is a very different kind of scenario.
What's your thoughts about AI becoming aware? You're talking about reflection, and you hear lots of stories and lots of, if like, propaganda about AI becoming aware. That opens up a huge problem regarding humanity and the law.
I think that it's one of these things that we can't do yet, and this is sort of the ultimate challenge of AI. It's been eluding us for the 50 years we've been doing AI, and I'm sure it'll elude us for many years longer. I think one of the challenges is that we don't really know we don't understand what self-awareness and complex action is, so how do we convey it to a robot? The question is, when is it going to happen?
My question is, some people think it's already happened. I don't believe that. I think it is just a machine. Yeah. But I can see it potentially happening at some point.
Yeah, I would say it's possible. It's going to happen eventually. I'm often worried about how soon it could occur, because
we're not ready for that.
Exactly, absolutely. I'm not ready for it. I'll be out of a job. Everyone will be out of a job, and we just have to be ready as a society to say this could happen quickly and disrupt us in many ways. I don't really believe that we'll have this massive singularity type disaster explosion, but we will be in a situation where we need to be thinking very carefully about what people will do and how they'll live in a world where our machines appears to us.
Yeah, that's almost human.
Yeah.
Thank you.
Hi. Given that we're part of what we're talking about is the blockchain, there's a whole movement and almost a foundation in a lot of the initial coin offers and other things in the community that says that because we're a distributed peer-to-peer technology enabling new things, that the organisation that implements that should be a so-called distributed autonomous organisation, right? Which in effect is really saying that we're going to reduce what we're going to do to a set of rules and an algorithm and maybe put it in the blockchain. Right? What's your view of the practicality of that?
I think that centralisation creates so much efficiency. So you've got the ability of Google to just amass huge amounts of data because they're a central organisation. It's really an edge that is difficult to overcome. We see in speech recognition, Google's like way ahead of everyone else. But open source alternatives, which is really about pooling data from a community, it's catching up. But I think that this kind of robotics AI game is one purely led by who controls it and can get the data together. Maybe this blockchain decentralized approach has potential, but the leader, I think, will have to be centralized.
The question's more around dealing with, for for one of a better, uncertainty. One of the big things an organisation does is deal with uncertainty.
Mm-hmm.
Is that possible to algorithmize, if there's such a word?
Oh, well, you saw before there was this guess that thought I was 90% male. Not thought I was 90% male. Thought there was a 90% chance I'm male. Throughout the whole organisation, so throughout this AI programming, as much as possible, the whole sensing process is very much probabilistic and all about uncertainty. But then when we put in and try and give it some goals and intent, we have to ultimately say, well, once it's 90%, it's good enough for me, you're a male. And that's, at the moment, that's the barrier, that's the challenge with AI. But being able to push the whole way through the process, look, you're 90% male, 90% chance of being male, so now, because I'm uncertain about that, rather than greeting you with hello sir or hello ma'am, I might just greet you with hello. And being able to push through those probabilities and uncertainty all the way through is part of the challenge that's of AI, yeah.
Hi Ben,
Yeah.
Thanks for your presentation. So I'd like to come back to this idea of the singularity hypothesis, delve into the sci-fi territory. So in economics, there's this idea of the profit motive, and there's a guy called Robert Heilbroner who writes about it in his book, The World of Philosophers, and he says that over the time, mankind has ensured its survival by three means.
Yeah.
So tradition, command / totalitarian rule, and the market system, which is modern times. So how would AI fit into this paradigm once it does become self-aware? Will it adhere to our market system, or do you think that maybe like a command would be more efficient?
Wow.
To ensure its own survival?
I think this is maybe one for the floor to discuss. My take would be that robots have the potential of being law themselves. If you in 20 years' time, when robots are cheap enough, we could reshape entire continents by just having 1,000 robots just digging constantly for us. Like 2,000 years ago, 1,000 years ago, when the pyramids were built, when the Chinese emperors were building their palaces, they just used hundreds of thousands of laborers to do work. We'll be able to have hundreds of thousands of robots for each of us doing the work for us. And that means that maybe the robots will just impose by themselves. It's impossible to park in the wrong location because your car's doing the parking for you. It's impossible to murder someone because the robots are enforcing the rules. And I think this control aspect is probably something where it's almost the law is embedded in our environment around us, and that we no longer think of it as something we have to comply with. It's just as much a part of living as the idea that should it be illegal to not be able to pick your own head off your head and put it somewhere else. It's just impossible, physically impossible. In the same way, robots will make certain things physically impossible in the future. But maybe other people have other thoughts on this question.
Thank you. It was a hard question. So.
I think it's a good answer.
There we go.
Well, firstly, wow, I love that talk, especially how the robots have gotten smarter and better at playing football.
Mm-hmm.
Maybe it's not too long before we see a robotic Cristiano Ronaldo.
Oh, yeah. Well, the goal is to have it to beat humans by 2050.
Okay.
I think at this rate, we're probably going to get there sooner, maybe 2030.
Well, note my Barcelona bias because you cannot have a robot replicate Lionel Messi. Anyway, on to a less controversial topic than football. Now, you would be aware in your research in machine learning and how they can be used for good and bad.
Yeah.
You would be aware of the deep fakes phenomenon.
Oh yes. Yeah.
Now, we've seen the fake Obama video, the fake Gal Gadot video that is not entirely convincing. But how far do you think we are from a convincing Trump video where he says, "I hate Canada, I'm nuking you all to kingdom come," and that it looks convincing that it could be a national security issue?
Well, if you look at Photoshop today, they're almost indistinguishable from the real thing.
Yeah.
And I would say that we're not too deep fakes. For anyone who hasn't seen it, it's this idea of basically photoshopping someone else's face onto a body in a video. And really, a deep fake is just a whole lot of Photoshop strung on off the other.
Yeah.
And if you use the latest versions of Photoshop these days, they've got content-aware deleting. They can do amazing stuff. Many of the deep fakes themselves are pretty close to convincing. Some of them are terrible, some of them are good. And the barriers to entries have dropped so much down that you don't have to be an AI expert. You just download the software and it works. So I would be saying like in a couple of years. Yeah.
Sounds like fun.
But this is just going to be a new kind of trust that we no longer can trust video as an authoritative source. We're going to have to embed in videos, in cameras, a chain of custody, for example. Like it came off this sensor, we trust it now because of this proven chain of custody, as opposed to because we look at it and we think it's convincing. And it's the same with everything, right? Who knows if the Trump video about the audio about the sexual harassment was truly real. It sounds like he admitted it, so it was real. But I mean, a good impersonator could have pulled off something like that already. So there's already this lack of trust.
Yeah.
It's just going to mean we have to care about it in other ways.
All right, we've got one last question over here.
Thanks so much for the great presentation.
Yeah.
It's very engaging. Just a really quick question about information security. Are there any measures that you're taking personally to make sure that your data is protected? I mean, by way of VPN or anything similar to that?
Yeah. Yeah, we've got our lab with robots. We don't actually store that much personal data, so we're kind of safe just because no one cares about our data. But we do have all of our labs sitting behind a firewall now, and we block anything incoming. It's kind of minimal security. It's the same kind of security you'd have in any corporate environment. I think that robots, this will be a whole different conversation in a few years' time when we have a robot in every home, like Google Home, where now we have to guard everyone's home, even despite the security. They have to guard everyone's home despite the way they've configured their home network, and then face the potential for breaches. There's a whole. Google's been amazing in terms of keeping their data private, but almost every other company in the world has had a major breach. Robot manufacturers don't care about security yet, and so we're going to have these breaches, and who knows how to solve that. Yeah. Thank you.
All right, let's thank Ben Johnston. Thank you very much.